The sheer scale of the Stratofortress is overwhelming. A true relic of the Cold War, slowly decaying in this forgotten hangar. Once a symbol of air power, this Stratofortress now sits derelict, its fuselage scarred by time and the elements.
All right, team, focus on the forward fuselage and document everything.
Roger that. Moving to the landing gear.
Checking the engine pods.
There's the source of the leak, right where I'm pointing.
Clear this dust here. Let's check the part number. Look at the corrosion on these blades. We've got major pitting right here.
Yeah, the entire housing is compromised. This section here is worse than we thought. Get some close-ups on the pitting.
Got it. Looks like stress corrosion around the fastener.
Look at the corrosion on this bundle.
We need to replace the entire segment before we power it up.
The corrosion on the fuselage is worse than expected.
Yeah, make sure the LiDAR captures the full depth of that damage near the wing spar.
Look at the extent of this corrosion at the stabilizer base.
Got it. Moving to the antenna mounts now, see the loose cables?
Reading steady at 2200. Corrosion is significant here.
Noted. The stress fractures align with the historical data.
Look at the corrosion here on the fuselage. It's significantly worse than the initial report suggested.
The engine pods are critical.
We need to prioritize the structural integrity around the landing gear.
Copy that. The scanner data should give us a clearer picture.
Go ahead and mark zone 3.
Confirmed. Spraying now. Looks heavy.
Okay, focus on the starboard actuator housing. The corrosion here is significant.
Got the shot.
The structural integrity looks compromised near the bulkhead.
The extent of the deterioration is staggering.
We're seeing heavy pitting on the compressor blades, fully exposed to the elements.
I've marked the area for the NDT team. The crack runs almost 8 inches past the seam.
Look at this corrosion on the main bus. They stripped everything out of racks 3 and 4.
Position the next array just forward of the seam, B.7.
Reading confirmed. Logging the coordinates now.
This section here is completely compromised.
I'm photographing the missing mounts now. The rust is significant.
See this red X right here? The fatigue stress is critical.
I'm updating the model now. That's a primary structural concern.
Look at the stress points on the swept wings here.
We'll need extensive reinforcement around the landing gear housing as well.
This section here, the corrosion is extensive.
It matches the damage on the actual aircraft in the hangar.
We should prioritize the engine mounts first.
The primary concern is the integrity of the landing gear mounts, shown right here. It correlates directly with the stress fractures we observed yesterday.
We have to prioritize the engine nacelles before the structural integrity is compromised.
I agree, but the stress fractures on the bicycle gear are a higher risk.
We need to reinforce this section here.
Yes, the stress fractures are significant along the wing route.
And the fuselage near the landing gear needs attention too.
The fatigue data confirms the stress fractures on the wing spars here.
Yes, the red highlights match the assessment.
This red marker indicates the fuselage section that needs complete dismantling.
The engines require extensive cleaning before reinforcement.
As you can see, the extraction requires precise coordination.
We need to focus on these gear systems first, then the engine pods before we address the fuselage reinforcements here and the internal assemblies.
We need to prioritize the structural integrity of the wing spars first.
Agreed. The corrosion there is severe.
And the landing gear needs immediate attention too.
Shackle is secure on this side. Okay, we have the jack positioned. Easy now, bring it down slow. A little to the left. Hold it there, watch the clearance. We've got the primary supports cinched down. Make sure the outriggers are clear before we lift. Bring the aft platform 5 more inches. Copy that, watching the clearance now. All right, stabilize and lock it down.
As the cables slowly take the load, the old bomber groans under its own weight for the first time in decades, shedding the dust of years.
All lines clear. Confirmed, ready for TOW.
All right, team, slow pull initiated. Watch the starboard wing.
Platform stabilizing, move her out.
Adjusting course now. Hold steady on the main platform.
Roger that. Movement confirmed and stable.
Steady on the right side, watch the cable tension.
Rolling forward, we are clear on this side. Control, all braces secure. Proceeding as planned.
Roger that. Watch the port side clearance. Keep it steady on the starboard side, watch the clearance.
All right, bring it back 20 feet, watch the wing tip.
All right, lift sequence engaged. Confirm pressure readings on section 4.
Pressure stabilizing. Proceed with caution. We are clear for movement.
All teams confirm green light for movement.
Green confirmed. Moving slowly.
Watch the starboard outrigger. Clear the obstruction. Control, this is platform 2. We are holding steady at grid reference 4. Minor debris fall noted.
All right, team, push forward slowly. Watch the starboard engines.
Roger, maintaining 2 knots. Clear on this side.
We're showing stress on the starboard gear. Keep it slow.
Copy that, increasing power to the forward pods now. Check the tension on strap 3.
Roger that. Radio says we have 5 minutes until the next checkpoint. Clear on the left side, moving forward.
Roger that. Watch the stabilizer top. Wind is picking up.
Look at the corrosion on this manifold. Yeah, pressure's dropping on line 4. Keep it steady, watch the clearance on the right wing.
Platform speed holding at 0.5 knots.
All right, team, the platform is secure. Start with the starboard wing, easy on the pressure.
Okay, bump the pressure up to 1,000. Copy that, coming out now.
The washdown is complete. We can move to the structural assessment phase now.
Affirmative. Bring up the schematics for the wing spar.
Inside the belly of the Stratofortress, a time capsule of cramped corridors and structural ribs untouched for decades.
Push it, push it.
Careful of the edge, she's catching right here.
Okay, it's clear now, keep going.
Watch the dials on the left side. Don't oversaturate the panel. Keep the pressure steady.
Here's the hose, careful with the pressure. Got it, let's clear this mud out.
Use the orange spray on those ribs.
Okay, hold it right there for the photo.
Right here, the mounts are showing fatigue. Note the stress cracks on this joint.
Okay, documented. I'll move the light. That bracket measures 42 millimeters. Make sure the marker is secure, John.
Roger that. All markers placed. Right there. Make sure you get a good shot of that stress fracture.
Copy that. It's logged and marked for the replacement schedule.
Scanner 1 is online and calibrated.
Kicking off the first sweep now. The data stream looks good.
Corrosion noted near rib 402. Photo taken. Let's move to the next seam.
We need you to verify the wiring harness routing here.
See this section? That's where the interference is occurring.
From here, we can see the extent of the work. Every one of these bright markings denotes a critical repair point on the fuselage structure.
All right, lift it up steady. We need to clear that fitting.
Watch the edge, bring it over to the mark.
The restoration effort focuses on these structural rails. Ensuring every fastener meets the precise torque specifications is paramount.
This one goes to the forward fuselage section.
All right, let's get it onto the transport jig.
Double check the part number before we move it.
Okay, easy now. Watch your fingers.
Almost there, clear on this side.
Torque set to 50. The stress readings here look solid.
Confirmed. Panel 7B is within tolerance.
Check the leading edge on row 3. Looks like we have some pitting near the root.
Hold it there. Right along this edge, you can see the marking.
Yeah, and the leading edge on the next one is showing fatigue as well.
All right, bring her down steady, watch your cabling. We've got good clearance here, set it down gently. Look at the wear on this turbine blade, it's almost out of tolerance.
We'll need to replace the entire assembly then.
Easy now, bring it down 5 centimeters. Watch the clearance on the starboard side. Make sure the seal is tight on the forward latch. Roger that. Applying torque now. Okay, easy now. Watch the hydraulic line.
Got it. Hitting the first bolt now.
2 clicks on the wrench.
All right, this joint is fully coated.
Looks good. Proceed to the next linkage and log the pressure.
Did you get the click on that one?
Yeah, 7 and 8 are secured.
All right, moving on to the center mounts.
Keep the pressure steady. Okay, moving to the last rivet.
The application of the specialized primer is crucial for protecting the engine's delicate components during the restoration process.
According to the schematic, the primer coat is fully cured.
All right, let's prep the forward pods first.
The nacelles require a precise application to ensure the Cold War era camouflage is historically accurate.
Then. As we move along the fuselage, the sheer scale of Stratofortress becomes apparent. The new coating provides
Forward gear pressure stable.
Confirmed. Data uploaded.
Engines are reading green across the board, ready for spin up.
Check the voltage on auxiliary bus Charlie. Reading nominal. Cycle complete on the dampener.
Hydraulic line secured.
Roger that. Initiating the diagnostic sequence now. Stand clear.
Pressure stable at 5,000.
Confirmed. Cycling complete. Gear shows locked and secure.
Diagnostics connected, running the sequence now.
Roger that. Activating bus 1, then 2. Standby power check. Master caution clear. Bringing the radar altimeter online now.
Roger that. We show stable voltage on bus 1 and 2.
Cable secure on pod 3. Diagnostics are showing green, rolling now.
Ramping up to diagnostic speed now.
Vibration steady at 400 RPM. Alignment looks good on screen 3.
Readings are clear, Cap. Everything's in tolerance.
The pressure differential on the forward pod is fluctuating.
Yep, I see it here too. Rerunning the diagnostic sequence now.
Diagnostics are complete. All systems indicate full operational status. Clear the area for engine start procedures.
Look at the state of the radar dome here. It was completely corroded.
And now it's fully integrated.
The work they did on the fuselage alone is remarkable. I lift the photograph again and slowly turn toward the large cafeteria window where the massive hangar doors stand open outside.
From this old photo to the bird out there, it's incredible.
The restoration team did an outstanding job on the fuselage.
Check the hydraulics on the main gear. Ensure pressure is stable.
Wilco, already on it. The left outrigger looks good.
The thrust figures on these pods are exceeding the baseline.
The fuel efficiency modeling confirms it. She's ready for deployment.
The structural integrity looks good from here. We have a minor fluctuation on the starboard engines. Run level 2 diagnostics.
The hydraulic pressure on engine 3 is still fluctuating.
Check the bleed air valve schematic.
Confirm hydraulic pressure levels.
Pressure is good. Electrical stability and propulsion systems are ready.
Copy that. Cleared for movement. Check the pressure on hydraulics 3 and 4.
Reading green across the board, sir.
Bore scope clear on engine 7. Ground check, confirm auxiliary power engaged. Solid copy, auxiliary power engaged.
The pressure differentials look nominal here on the checklist.
And the sensor array on the fuselage checks out. We are clear for deployment.
Checklist complete. Ground, this is the flight deck requesting taxi clearance. Roger, we confirm the aircraft is officially cleared and ready for deployment. Good work, gentlemen. Over. Maintain slow speed, watch the starboard wingtip. Copy that, speed holding steady. All right, slow it down to 5 knots. Watch the starboard clearance, we're clear on the left. Check complete, tower confirms green. Roger that, proceeding to runway. Ground control, we are approaching waypoint 3. Roger, hold position for crossing traffic. B-52, you are clear for final approach to the staging area. All systems check complete.
Roger that, commencing final checks. All parameters are nominal across the board. The wing flex is within acceptable limits.
Good. Keep monitoring the fuel flow.
All systems green, hydraulic pressure nominal.
Confirmed. Taxi clearance granted.
Ground power is stable. Initiating pre-flight sequence.
Copy that. Cycling flaps now. Clear the area.
Flaps and slats checked. We are good to go on this side. All right, confirming the ordnance load is secure. Let's signal the tower.
All stations, this is the flight deck. Give me a final go to go. Ground confirms green. Roger that. Stardust to command. Final readiness status confirmed. We are green for launch.
Roger that, Stardust. Waiting on authorization.
Roger that. Command. The B-52 is full mission capable and cleared for operational service.
Ground, Clipper Heavy, taxiing to runway 23.
Clipper Heavy, winds 290 at 10, cleared for takeoff.
We did it! After all this time, she flies!